Now this is all we're going to say about the equation with non-constant coefficients. Let's return to the constant coefficient equation. The constant coefficient equation is ay double prime plus by prime plus cy equals 0 with conditions y of, well, I intended y of t naught. Let's see if I can. Y of t naught equals y naught, y prime of t naught equals v naught. And this equation, as we've seen, is solved by assuming a solution y equals a e to the RT. We get the characteristic equation. Solve it for R, and then fit the solution to the initial conditions. And the solutions have a nature that depends on the discriminant of the quadratic characteristic equation. That equation can have two real solutions, one repeated real solution, or two complex solutions. So we're going to do examples. So example 1, we're going to consider the equation y double prime plus 5y minus 6 equals 0 with initial conditions y of 0 equals 1, y prime of 0 equals negative 1. And the initial conditions won't usually be this simple, but this will serve to amply illustrate the process. So if y equals ae to the RT, then y prime is RA e to the RT, y double prime is r squared a e to the RT, and our equation becomes r squared plus 5r minus 6 equals 0. Now I've left out the steps where we actually substitute these into the equation. We've seen those steps already, and we understand that every one of these terms is going to have an AE to the RT as a factor, so that when we divide the step we get when we substitute, if we divide the equation we get when we substitute by AE to the RT, we're left with this equation. And it's assumed that you've seen this enough times that we don't need to fill in that step. And we'll assume also that you know how to solve a quadratic equation. This one can be easily solved by factoring, but of course we can always use the quadratic formula if we can't see how to factor. The solutions to this equation are r equals negative 6 or r equals 1. This yields the general solution y of t equals a e to the negative 6t plus b e to the, well, for r equals 1 it's 1t, so we'll just call that b e to the t. Okay, we'll write that once more. Y of t equals a e to the negative 6t plus b e to the t. Now, y prime of t in this case is going to be what? Negative 6a e to the negative 6t plus b e to the t. And assume you can take these derivatives. We have the initial condition y of 0 equals 1. Well, y of 0 is going to be ae to the 0 because negative 6 times 0 is 0 plus b e to the 0, and that should equal 1. E to the 0 equals 1, so we have a plus b equals 1. Our initial condition y prime of 0 equals negative 1 implies what? That negative 6a e to the 0 plus b e to the 0, bad looking e there and I'm making it worse, equals negative 1. And simplifying this, we get negative 6a plus b equals negative 1. So that's two simultaneous equations in A and B we're going to be able to solve for the constants A and B. So our simultaneous equations are A plus B equals 1, negative 6A plus B equals negative 1. Various ways to solve this system of equations. We could solve the first one. We get B equals 1 minus A. If we substitute 1 minus A here, then we have negative 6A plus 1 minus A. Negative 7A would equal, negative 7A plus 1 would be negative 1, and A would be 2/7. Alternatively, we could subtract the second equation from the first. We'd get we'd get 7A equals 2, so again A equals 2/7. Not going to go into detail on solving a pair of simultaneous equations. That's something at this point in your mathematics education we simply expect that you can do by any of a number of methods. We can write this as a matrix equation and invert the matrix.